In this lesson, we're going to implement point lighting. In the last few demos, we've been using directional lights, and we said that directional lights don't have position in 3D space. They're infinitely far away. Now, we rendered a proxy model just so that we could see it actually on the screen, and we could see what direction our light was facing. But in reality, the directional light is infinitely far away. But it has no position in 3D space, right? But that's just the opposite for point lights. For point lights, the light has position, but no direction. In fact, you could say that the point light radiates light in all directions. Think of this like a light bulb inside of your living room. In your living room, that light bulb radiates light in all directions, but it also has a distance that it influences. So the further away we get from the light, the less influence that light has. That's called attenuation, and we can implement that in our point lighting model as well. So let's take a look at the point light demo in your 5.4 lesson. This now, instead of the directional light, we're going to use a point light, and instead of our blend-Phong effect, we're going to use a point light effect. The point light effect I'll get to in just a moment, but let's take a look at the point light class. And you'll notice that the point light class, rather than having directional data, it has position, which is a vector 3, and radius. That radius is how far this light influences. Okay. Now, if we look at the point light effect, you'll see that we have a few new data members here. We have a light position and a light radius. Now, instead of a light direction, that maps to, if we look here, light position and light radius inside of the vertex shader. So the vertex shader then still has our same attribute layout. We still have a texture coordinate and normal and a world position that we're passing through. We also now have this new output that we've included in our VS output struct called attenuation. And that attenuation is what I'm talking about as the light falls off. And there's lots of different attenuation models. We're going to use a linear attenuation model. So this code should look familiar to you, but what's new now is we're using the light direction that we compute here in this attenuation model. And let me mention something about this calculation. Let me just show it to you pictorially. So this is the surface, our object position, and this is our light position. And rather than the light direction being supplied, what we're going to do is compute the light vector by subtracting the object position from the light position. And that's this code here. Now, the attenuation, we're simply going to take the length of that light direction vector. How far away? That length GLSL intrinsic gives me the length of that vector. How far away is our surface from the camera? And it divides it by the light radius, so our passed in light radius uniform. And we're going to subtract that from the value 1, so 1 minus that value. So this is going to be a value somewhere between 0 and 1. And again, we're going to clamp that so to make sure that it's between 0 and 1. It doesn't go negative. That attenuation value is going to be used inside of the fragment shader. Inside of the fragment shader, we have our camera position, our specular color, our specular power, but you're going to notice we have a light position again, and if we look at the first line of our fragment shader, we're recomputing the light direction. Well, we just did that. Why are we redoing it? And the answer is, well, because in the previous blend-Phong shader, we didn't have position for our light. Our light was infinitely far away from the surface. But now we do, and when the point light gets really, really close to the surface, well, now the direction per pixel varies pretty significantly versus the vertex. If we were to compute this purely in the vertex shader and pass that light direction through, then you would see some pretty significant distortions in the specular highlight when the point light gets really close to the surface. So we still take the camera position minus the world position to calculate our view direction, and the rest of these calculations are from blend-Phong. The n.l for our diffuse, half vector, and n.h for blend-Phong. This code is the sampled color and ambient, that's the same, but now we're changing how we calculate the diffuse. So we're going to calculate the diffuse just like we did before with respect to Lambert's cosine law, but now we're going to apply the attenuation factor to that diffuse. And likewise for specular, we're going to take the same specular that we did for blend-Phong, along with still storing the specular map inside of the alpha channel, but now we're going to modulate that by the attenuation factor. And now we have the same code that we did before where we have each of those terms additive in our point light fragment shader. The color becomes the ambient plus the diffuse plus the specular. Let's go back to our C++ side. Okay, take a look at the point light demo.cpp. In the point light demo.cpp now we're loading those two fragment shaders, compiling them, linking them, loading a sphere object. We're building the vertex buffer just as we did in the last demo. We're loading the earth@day.png texture. We're creating our vertex shader by invoking shader program.initialize. And in this case, the shader program is our point light effect shader program. All right, so we're going to instantiate all of these variables and specify this attribute layout. It's the same attribute layout as before, but it does have a few new shader variables. Finally, we instantiate a point light and a proxy model for a point light, and this proxy model looks a little different. Instead of an arrow, it'll just be an icosahedron. And now we're going to call, instead of update directional light, we have update ambient light, update specular light, and update point light. Let's take a look at that code. So the point light, we're just going to change its intensity just like we did before with home and end for the directional light. We can have more or less impact of the point light with the home and end key. Now we're going to move the point light around with the IL, right? So IL, JK, and N and M. So the JL moves it horizontally, IK moves it vertically, and the NM moves it on the Z-plane. So you can change this code to suit you better, but this is just for demonstration purposes. We wanted the ability to move the light around to see how it impacts the scene. So we're going to set the position based off of that movement. And we can also update the light's radius with the V key and the B key. And you'll see how that impacts here when we run the demo. Back into our draw call. Just as before, we have the same look and feel of our draw call. We have draw elements at the bottom for the object that we're rendering, our model. We know how many indices because we tracked that in the initialize function. And the only thing that's different here is we're using a different shader program, and there's a few new values that are being passed in, specifically the light's position and the light's radius. Rather than before, we passed in the light direction. And that's it. Let's take a look at how this runs. Okay, so there's our little proxy model. It's a spherical object. And there's our sphere with the earth map to it. And you can move the point light around. Let's see how this works. So I'm going to move the point light around. I can move it vertically. I'm using the I, J, K, L. So I and K to move it vertically, J and L to move it horizontally, N and M to move it along the Z-axis. And notice how the light is changing as we do that. All right. And I can also change the influence of the light. Notice now I'm going to use V and B. I'm pressing the B key to reduce the radius. So I'm leaving the point light as it is, but I'm going to press the B key a few times to reduce the radius down. Additionally, I could have just backed the light up. So if I back the light up and get it further away, notice now that the influence is getting much, much less until it's finally black. Now I can also change, instead of the radius, with the home and the insert keys, that was the O and the P key for the specular. With the insert and the delete key, I can turn the specular off. But for the home and end key, now that changes the influence of the point light. Right? And then that's page up and page down. That's for ambient, a little bit of ambient. So that is our implementation of the point light model. In the next lesson, we're going to talk about spotlights.